Good afternoon, everyone. We're right at the top of the hour, so we're going to go ahead and get started. First off, my name is Tiffany Westbay. I'm the Membership Director here at America Makes, and I'll be your host for today's America Makes TRX webinar series. A little bit of background on the series before we get started here. We created this platform, and it's called the America Makes Technical Review and Exchange webinar series, and that's long for the TRX that you see on your screen right now. But by doing this, we were able to find a way to keep the conversation going. And basically, it was a means to continue the dissemination of information to the additive community at large. A quick note before we get started, we are going to have a live presentation, but each attendee will be muted upon entry. So if you do have a question during the presentation, please feel free to insert that into your Q&A box, and I will give that over to our presenter during the Q&A session. So today's webinar will be presented by Alexandre Donadieu from 3Year Mind. He joined 3Year Mind back in 2017, where today he's currently the Vice President of Operations. During our time today, Alex will be presenting on how 3D service bureaus have hit their capacity to manually process additional 3D file orders. The realization that simply adding people is no longer solving the problems has enabled Alex to show us how adding software into your production workflow is becoming a must-have. Alex will give us a practical solution to overcoming the barriers in growing your production and show you how to multiply the effectiveness of your engineering team. And with that, it's my pleasure to hand it over to Alex.
Thanks a lot, Tiffany. It's a pleasure being with you. Thanks a lot for attending. As Tiffany was introducing, I will be presenting basically how we do define workflows, digital workflows for managing orders for additive manufacturing, managing data for additive manufacturing products, and managing the jobs on the shop floor. So the goal of this presentation here will be, first of all, to because digital and software is usually something unknown and something that is being discovered in the area of additive manufacturing. I want to do a quick introduction about the ecosystem of software available in the market, but then share our best practices and the way we want to design, share our best practices and the way we design our software ourselves. There are two things I want to share here: is how do we manage the orders, basically the order intake for operators or engineers that need to produce parts for additive manufacturing, and there is a large amount of complexity here in how do you manage the 3D file, the specification, and so on, that requires to build efficient workflows. And then how how do you manage the production on the shop floor, and how the softwares for shop floor management are different than the traditional digital tools that exist in the market already. Then we'll be having a session on Q&A. So very quick introduction about 3Year Mind. So we are German, originally from Berlin, actually, a German company originally. We are now also an American company and positioned here in Michigan. Proud member of America Makes, a very recent member. So we design a software to optimize the workflow from design to production. We are more than 60 people all over the world and positioned in more than 6 locations today. We're still pretty young, and we're trying to bring awareness in the market about how important it is to manage the data for additive manufacturing, to standardize the data, and to automate the shop floor. The idea of 3Year Mind is basically to automate the shop floor, the additive manufacturing shop floors, and optimize the data flows from the design to the machines. So this is a quick introduction about our company, and then I would like to start with the 3 main areas of software for enterprise, for industrial companies, basically. They are, from our vision of the market, 3 main components of softwares There is the commercial, the business management part, what we could call ERP systems, basically. This includes fulfillment, the fulfillment of the orders, the order processing, from order entry and specification up to payment and cost control. The analytics as well, controlling from the orders from the customer through the shop floor up to the customer again, delivery, defining the service level, defining the different KPIs, the key performance indicators of the supply chain of the company. And then supply chain management in terms of defining the supplier schedulings, the purchasing indicators, and so on and so forth. So from the commercial side, it would be defined as, like I said, like an ERP part, but for Service Bureau, it's like managing the flows of their orders with customers. So this is the let's say the front end part of the softwares. Then the second part would be the production, which is what we would call usually manufacturing execution system. And this includes the production planning and scheduling, machine connectivity as well, so connecting directly with printers. In the traditional manufacturing industry, it's something that is well developed and still in the process to be done in additive manufacturing. So monitoring the data, capturing the data, the process information, for example, but also knowing when the machine is running or getting errors, updates. And when I speak of machine connectivity here, again, I want to stress on the fact that I'm speaking of generic software. So I'm not speaking of the software of machine themselves, like let's say GrabCAD for Stratasys. I'm speaking of software that can connect different technologies, different printers, and collect data, standardized data from these different printers. Then there are the production analytics, knowing, let's say, the mean time between failure, the utilization rate of the machines, and of course, tracking quality insurance, material batches, and so on and so forth. So this is basically the software we can find in the shop floor, and that can help the engineers, the operations engineer, to be more efficient on a daily basis. The last pieces of software that we can find in the industry is basically the innovation software. Basically, it's about design and engineering. So idea management, requirements and specification management. So it's more of the upstream softwares, basically. So managing the product, managing the life cycle of the product, of course, the product design, identifying the manufacturing process up front for the design and based on the specification of the concept and ideas that the engineers design. And of course, the product data management. So this is basically the three main building blocks of complete enterprise software that we think should be the full scope of the software we can find in efficient organization. And the way we address it is we define three pieces of software in 3Omind to address these three different points. First of all, the order management, which is like the order intake, like I said. What we call the Agile MES, basically optimizing the shop floor itself, and making sure that the jobs are scheduled the right way, that the parts are tracked, and that the shop floor is automated. And the additive manufacturing part identifier, which is collecting data from each part and identifying the best use cases for additive manufacturing. And today I will be focusing mainly on order management and Agile MES. So how we envision an efficient way to collect from engineers and from the users of the end users of additive manufacturing, how do we collect their requirements, how do we price and cost the parts. That's the first step. And then, of course, once these requirements, once these orders were specified, how do we send this to the shop floor and how we organize in a better way on the shop floors. So one important thing here is that we believe, and this is the way we want to approach the software industry here for AM, is we don't want the companies to have three different type of, let's say, different software for managing these three pieces. We want this to be done in one central platform with standardized data from the different modules of the software. So this is what we call the agile manufacturing platform, and we want this to be manageable in one central environment. This is, and we address this in our software. So the first point, the entry point, and I think this is a starting point for us, is to have an efficient data collection as early as possible in the process. So it's being able to have all the part specification that can be technical specification, that can be customer specification, as soon as possible in the process, to enhance the communication basically between the shop floor and the operation engineers and the design engineers. A good order intake and order management system is also a guarantee for us to increase the speed of to production and have like reliable communication between the different entities of an organization. Defining also as precisely as possible, as soon as possible, all the requirements for the parts is also to us ensuring the output quality for producing the parts. So now I'm going to show you very quickly a quick drawing on some feedback we received from actual users of additive manufacturing. Application engineers that need to order parts, and so this is the way basically we approach the design of our software. We don't come and design from scratch something and give it to our customer. We work with them to define what would be the best workflow for them. And working with them, we basically identified with some application engineers and engineers that basically are ordering parts. We identified 3 ways of ordering, which will be displayed here. And the best way that users identify the way of ordering is to use an inventory. They want to be, at the end of the day, able to have a digital inventory. So this is one of the big findings we had with designing our software and working with our customer, is that they want to be able to digitize their warehouse somehow and be able to select the part that they want to produce. So the first entry we want to provide is a storefront for customers, a digital inventory, and making it possible for let's say maintenance operators or application engineers to select the part that they want to find and to automatically order them. The other option that they can face is that there is no part in the inventory, and of course it's often the case today because companies are still looking for the use cases. So we want to be able at this point to address 2 situations where there are 3D files existing, and this can be the case for mature company with additive manufacturing, but also in some occasion no 3D file is available. In this case would be, for example, for spare parts. Some of our customers have a lot of parts all over the place in their organization, and sometimes some legacy parts with a low rotation rate and very old parts as well, and they don't have any data about this part, any 3D data. So we want to make it possible also to order and to create and to digitize existing physical parts through our ordering system. So basically, if a 3D file exists, it's very simple. You create a new part, and you go through ordering, and I will show you afterwards how we see this part. And if there is no 3D file, we define a starter workflow, which also help at the very beginning of the process beginners, let's say, to store their part, identify whether it's a good use case based on some information inputs, and then order it. So I'll be showing you very quickly how our software works with the different scenarios. The first scenario would be, for example, an operator, maintenance operator that want to access to additive manufacturing, that has a product, know about his product, know about the service level of the spare parts, for example, but doesn't know exactly about AM. And we want to address this specific case and has no 3D file. So we want to be able to have a workflow for this kind of situation. And this is what we design here. This is the entry point for the less mature user. They could create a part, select the type of part that they want to create, define a name of the part, for example, here, a serial number, a department for the part, and then specify some technical aspects of the part, for example, the width, the height, the depth of the part. Here, for example, select the material class, let's say plastic part or metal part, let's say, and for example, aluminum. Define the tolerance that they need for the part. At this point, again, we want to we remember that the user doesn't have any file, 3D file or any specification file, so he has to do it manually. Select the level of complexity, a surface quality, and then some other specifications. So basically, this first order intake questionnaire, for the early stage, is also configurable based on the company and the business. So you can also add some economical criteria, because we believe at this point, at this stage, we want to assess the feasibility of the part based on also some economical and supply chain criteria. So define also the level of qualification needed, the demand frequency, the demand quantity, the minimum order for the parts, and the lead time, for example, here. Within 3 days, for example, and the supply risk, for example, medium. All of this information at the early stage will give an indication to the user when he creates his part on whether it should go for additive manufacturing or not. At this stage, in this early access order management system, you can give directly a feedback to the user whether this part is interesting for additive manufacturing in terms of economical and technical criteria. Then also a suggestion of the best technology to produce this part. So this is an example, but this part could be suitable for the MLS, for example. And then the user could submit the part to create a design. So this is the entry point we want to build. So the first very early access user doesn't have a 3D file, doesn't know how to use additive manufacturing. So we want to provide a feedback very early. I could detail also the parameters that we take into account to do this assessment later. The second workflow that we have, there is a 3D file available. The user knows about the specification, and then we have a complete order management system here. We can make it possible for the customer to select parts, to upload this part, to optimize this part, the 3D file, to transform them to STL and to do mesh healing. Then once the part is uploaded, we show to the user, this is fancy numbers here because it's a demo environment, but you can see, we can show to the user what are the material that can be used for these different parts, and the user can order directly here to different services. So it could be internal services or facilities or external facilities. So you can also have supplier portfolio management. Here we want to be able to input as many specifications as possible, including the post-processing, selecting the post-processing, selecting the parameters and the specification for the part. So this is the second scenario. And the third scenario is basically having a list of parts that were already ordered and having all the parameters for this part and reordering. So these three scenarios where the direct feedback from the way our customer would like to order the parts. And we believe it's very important to start with this aspect, being able to have this flexibility and this level of communication from the order intake stage. This is also the order management is basically giving the power to the engineers to identify all the parts that can be suitable for additive manufacturing, and also create new design and have the freedom of design that they want to have. So we want this ordering system to be accessible for any kind of situation, for spare parts, for early access users that don't have 3D design, that don't know about additive manufacturing, but also for those that already created an inventory and just want to reorder a part. Once we've given this freedom to the users, the engineers that order parts, there come a challenge because the flexibility of the order intake comes with a complexity of managing the shop floor. Because and this will be the second part of this presentation is how do we manage this flexibility on the shop floor? If you do give more freedom and more ability to create an on-demand production system, how do you manage the shop floor? How do you schedule your production system? The example here would be from a flight management, basically. Most like in software environments, a good example of very complex and agile software would be the software that I used in the airports to manage the different the workflow of the different first of all the plane scheduling, but also the seats that are bought by the passengers, and the seats Swift and etc. So this workflows are basically very complex and full of data. This is basically what we believe would be happening a bit with additive manufacturing shop floors. When you have a build, you want to be able to schedule a build, but also add a part at last minute, or maybe redesign a part last minute. Basically, what you can enable with flight ordering systems. So this is the example we wanted to follow to have like enable this agility for ordering like the engineers that want to order parts, but also guarantee an efficient shop floor. The other aspect and disruptive phenomenon that is happening in the industry is that the traditional manufacturing was mainly sequential, a sequence, very simple sequence where you had like designing steps and then prototyping and testing the products, then producing series and pre-series, and then of course controlling the quality of the product, for example, but also the material and so on. And now what's happening with additive manufacturing and also this flexibility of the shop floor is that designing could happen at any time throughout the product life cycle. Prototyping could happen at any time as well. And this flexibility comes with a lot of challenges. And this is why the software that we design should offer this flexibility and this and this data management. The statement and the assessment we've made in most of the company we've talked to is like the traditional tools don't fit. So usually most of the production planning for additive manufacturing today is done through traditional ERP system or manufacturing execution systems, or Excel sheets, for example, or paper. So this is what we see most of the time, and these tools don't offer the flexibility I was speaking of before. They are not able to manage the builds. They are not able to manage the flexibility that we need to have to enable a redesign process throughout the whole life cycle of a product. So this is where we implemented and design what we call the Agile MES and Agile Manufacturing Execution System, where so it's a system which is specialized for additive manufacturing first, and being able to drive smartly, let's say, the production of additive manufacturing and the complexity that comes with additive manufacturing production. So first of all, the first step of our best practices to build this manufacturing execution system is a connection with the order management I was displaying before. Being able to also manage the part prioritization, a little bit like the flights I was mentioning, like being able to take late order that is priority and put it in the right job, in the right build, in a machine that will be starting soon, for example. Having some custom workflows based on the very specific parameter setup that were designed within the shop floor, and of course, a dynamic scheduling, being able to redesign anytime throughout the production process, the scheduling. So this dynamic scheduling is especially something, and the part prioritization is something that we don't find in traditional softwares for traditional manufacturing. So the direct connection to order management is we've seen pretty much all the data intake that we can collect from the order management. The idea is that the manufacturing execution systems use this same data standard as the order management, and this is why we want this to be done in the same platform. And we want to offer the full visibility on this data on the shop floor. So basically, we want the operators to be connected to the end user and see exactly what are all the information that were and the specification that were collected and input by the end user, the customer, and then generate, based on these requirements, the exact production sequence. So we want this connection to be very seamless between order management. The shop floor of additive manufacturing have to be, and we believe actually that the real leverage of additive manufacturing will be connecting on the shop floor directly with customer. This is what we could call also on-demand manufacturing. But one key point for that, if we want to access to on-demand manufacturing, is to have a seamless integration between the order management and the manufacturing execution system. We don't want to do like what is done traditionally in the industry, having a system for just the order intake, which is different than the manufacturing execution system on the shop floor. So it's better visibility for production engineers, but also for the customer. In that regard, we want to make sure that we prioritize the parts the best way. So it will be based on different criteria. So basically, it could be based on the importance of a customer, for example, but also based on the actual queue of production. So multiple indicator and parameters could be used to prioritize parts, and we want our and you want your shop floor to be able to take into account this prioritization to automatically generate the planning. The other aspect is basically the production processes, and this is something that we've seen at our customers' shop floors, is that all production processes are basically the properties of the service bureaus or the shop floor. They design their different sequences with the data preparation, the printing, and the different post-processing methods they have. And so we want to be able to have a library of these processes and like give the hands of our customers on how they define all this production processes and their production sequences, the parameters they use for their printers, and the different steps they use to produce the parts. This is, let's say, the part where we believe we should offer the most customization to our customer, is basically creating very, very detailed workflows, like production workflows, and this will be basically the competitive advantage of our customer. So they define the different steps that they have to follow to produce the parts, and each part can have their workflow, production workflow selected. The dynamic production scheduling comes as a key building block here when we want to offer the flexibility I was speaking earlier of. A Gantt chart is like let's say, the backbone of any manufacturing execution system, that's for sure. And traditional manufacturing execution system all have this type of chart. Now the question is that how can we give the agility to change this Gantt chart when we have a new order and a new priority. Based on this prioritization rules, we want to be able to have this Gantt chart change very quickly and offer the best, let's say, live visibility to shop floor management. This comes along also with the estimation of print based on the build and the part and this part specification, and also being able to easily switch jobs between machine with the same parameters and the same qualification criteria, and of course follow the errors and the scrap parts whenever there is a problem on production of parts. This comes with basically one very important thing here, which we believe is essential when we build an efficient software for managing shop floors, that part tracking. One of the main complex aspects of additive manufacturing is managing a build. If we think of HP printers, for example, will be or in general power bed fusion builds, you will be managing a lot of different parts in the same build, and you want to be able to track these different parts, and at the end of the day, deliver this part to the right customers. This complexity is not something you can find in traditional manufacturing usually, and that comes with additive manufacturing. So being able to track each part and track each reference and each design is key in designing efficient manufacturing execution system for AM. The last part is maybe the part where the industry is still a bit struggling, I would say, and this is also the future of the industry, is being able to connect directly to different machines. So having a manufacturing execution system that can collect information from different printers and different printer providers. This is complex, and we've seen this in our work, because each machine has a different G-code setup. each machine has different parameters and different information they can collect. So how do we make it possible to have a software that can connect to any type of machine, and then that can collect the build parameters for controlling and quality purposes. And this is the future, and we're working a lot on that, and working with directly with technology providers to build this standard. So we want to be able to track the performance, the material basically, to monitor the workflows, and also have a live vision on the workflow and the completion of the workflow on the errors, and also defining the analytics. So defining the reports that we can extract from the utilization of the machines, then to do the return on investment of the machines, the failure rate of some identified machines, for example, the mean time between failure, the utilization rate, and so on and so forth. And then to draw from that experience and that data collection, some projection. So all the data we would collect on the shop floor directly from the machine could be used then for simulation. So to enhance throughout the life cycle of the product, the accuracy of simulations. So I didn't speak that much about simulation because at 3Online, we don't provide simulation. And we also believe that simulation is at the very beginning of its TRL. But a manufacturing execution system, from our point of view, should be able to collect all the data that can be used then for simulation and projection of customer needs. So it means like direct integration to machines, like I said, to get the real-time monitoring, tracking the quality, and controlling the machines, potentially to send the job directly to the machine. From our development stage, we developed the connectivity with approximately 5 machine manufacturers, and this is still in the beta phase. But we believe that this is the most important part to focus on in the future. And of course, all this information collected from the machines will be collected throughout the software and be used and extracted in the future. So this is so it's a lot of talking, it's a lot of explaining, but this is basically the overview of the way we define the best practices today of manufacturing execution system. This is the way we design our manufacturing execution system and our order management. We would like at least, even if our customer don't use our software, we would like to help the software industry to grow with these best practices. We want to share our ideas within the industry to have better workflows and data workflows. The complex part with software is always defining the return on investment on the use of the software. And we've been working with our customers to identify some part of these use cases. I will give you just an example of a shop floor, which is a service bureau producing mainly prototypes and tooling for big OEMs or automotive OEMs. Speaking of the order intake process, basically we identify in using like integrating order management system like ours, a time saving of 32 minutes per order. It was basically 92% time saving, which is basically tremendous. So we identified 3 critical steps in that process. Doing the quote and estimating the cost, because we can do instant quoting with our software, and also doing the design printability, because we can also assess the printability of a part based on, for example, the wall thickness, and based on the material properties and the technology specifications. Also, in having one tool that is integrated as a platform, we reduced in that particular case the number of interfaces from 5 to 1 to 2 interfaces. So this comes with a lot of seamless, like it brings a lot of simplicity within the process of managing orders. So using digital workflow in general also make it possible to define a return on investment, a very direct return on investment. Not even speaking about tracking parts or, let's say, qualitative rewards of using digital workflow. You can define a very straightforward business case for our customer. So that would be the let's say the conclusion of my discussion here, is that first of all, to have an efficient digital workflow, you need to consider two main aspects: the order management, and have the flexibility and the complexity that is required by engineers. Being able to manage this complexity on the shop floor with an MES that is not the standard MES that we see in the market, that are the MES that are designed specifically for additive manufacturing. And these two blocks has to be connected and standardized. So you don't want to use different systems for doing these different parts. The last thing is that this comes with actual business case, and you can define cost saving and quality improvement basically on using this type of software. This is so software comes with return on investment as well. So that would be my conclusion here. I would be happy to answer the question you have about that. It was a lot of things, I believe, but I'll be happy also to show a bit of the software if you want to, ask some specific points and how we manage things directly in the software.
Alex, thank you so much. That was such a great presentation, and we're so grateful for your willingness to share that information with us and for the software industry. I don't have any questions right now coming in through the audience, but I would like to kick off this session just with a couple I have here at hand. Those folks on the phone, if you do have questions, please feel free to put them in that Q&A box, and we'll make sure to get those answered for you. So just to start off, what are some of the key challenges you face in the software adoption in companies?
So basically, first of all, we face challenges in software adoption. So software adoption is actually a challenge for any software company, because one of the key points, once we've said what I said in terms of what should be the best practices to have a software dedicated to AM, we want to make sure that people use it. So in general, we speak about digital transformation. It seems like a big word, but actually it has a reality on the shop floor. And this is what we experienced a lot, is that we need the engineers, the application engineers, the operators to use the software. So to overcome that, the first thing is, first of all, support as much as possible our customers, but also it's about having user-friendly interfaces. This is the what we call the user experience in software, is a key point to make sure that the user will use the software. They want simple software, less click as possible, and the most automation as possible as well. I was mentioning like the prioritization, smart prioritization. This building block of AM software should be very important in terms of the user can specify very easily the priority of like basically the specification of his part, and it should be populated automatically within the planning system. So automation within the software is key, and simplicity of the interface as well to help the adoption.
Okay, thank you. So when you're approached by a new customer and they have an existing software ecosystem, what kind of things do you guys do to make sure that your software fits within their current system?
So that's an important point because I mentioned that there is the traditional softwares that basically cover the 3 points in different environments. But most of the time we come to companies that already have a legacy in terms of software. So the connectivity is there very important, and we not only want to be able to connect with machines, but also with third-party softwares like other ERP systems and so on, and CAD system. And this would be what we call API. So on a daily basis, we design application interfaces to connect to the local software of our customers. This is a crucial work we have to do with our customer, identifying the type of data and they want to exchange with their current software, because we cannot like disrupt the software environment totally. So we want to fit first to the existing ecosystem if it's required by the customer. And this, the answer will be the APIs.
Okay. Yeah, that makes perfect sense. And then how does 3YourMind go about guaranteeing the highest level of data security?
So that's a very interesting question, actually, because there is no straight answer about security. So security is a challenge as soon as we speak of 3D design and we work with suppliers to produce our parts and so on. The best way to ensure security is to be able to provide our software on premises for our customers. So to get our software on their servers directly. We've done this with a major aerospace and defense company we're working with. We passed through the highest level of security because we comply with their internal protocols. Because we install the software locally, the most direct answer would be to provide the local install. Then the cloud system would require much more control because and much more maintenance for data encryption at rest and in transit. So encryption of the design, encryption of the parameters. So the most direct answer would be go on premise, get the software on your servers, and comply the software to your protocols.
Okay, great. So I have one more question here before we conclude today, and I'm wondering, where do you stand in terms of 3D printer connectivity, and what are some of the main challenges to be solved?
So like I mentioned, first of all, to get to this connectivity, we need to address many different manufacturers, many different technologies, and that have different data, different standards. So the way to address this, and the way we think it would be the good way, is to work on a standard. We are right now working on a standard with a consortium of machine manufacturers, and doing case by case and developing APIs with each manufacturer individually would be too much of a work. So like defining specific interface with each manufacturer. So first of all, the way we address it is in defining a standard, and then making it possible to connect to that standard.
Thank you. Well, that wraps up my questions for today. If anybody on the line does have any questions, we have a moment or two here if you'd like to send them through. But Alex, I do want to take the time to thank you and your team again for preparing this webinar and presenting it to our audience. And for those folks on the line, if you have additional questions for Alex, his email address is on the screen right now, and it'll also be sent out in a follow-up email.
Thanks a lot, Tiffany.
Thank you. Okay, no other questions came in, so we're going to go ahead and conclude. Thank you a lot, Alex.
Thank you very much.